All right, let's continue. What was the last part? Part A. So y squared plus z minus 1 squared equals 4. Okay. Y squared plus z minus 1 squared equals 4. Now, if you don't if you don't see the x coordinate, this is just the circle equation in the yz plane, right? So if this is the yz plane, this is the circle with center at 1 and radius 2 units, right? So it is this circle. No, this is 1, but the radius is 2 units, okay? In the YZ plane, right? But we should consider this in the XYZ3 space. How we will do this? Well, okay, let me just draw it like this. So in the XZ plane, I have this circle, but then Z is free. It means you just translate this circle along the x-axis. When you translate a circle in the xy yz plane along the x-axis, you will get a cylinder, right? You have a circle, you just translate it. So in this so here is this circle with 2 units radius. Güzel çizemedim. Bir daha deneyeyim. Okay. And then so this is 1, z is 1, radius is 2 units, and you just translate this along the x-axis. So you get a cylinder like this, okay? Yani okay. So it's a cylinder like this, okay? It is the cylinder obtained by translating the circle y squared plus z minus 1 squared equals 4, right? In the yz plane along the x-axis. Evet. So I take the circle and just translate it along the x-axis. You get a cylinder. You see, you should get used to these equations and graphs, and to get used to this, you have to just deal with examples and exercises, okay? What about inequalities? For example, this one, the inequality z greater than 0 represents all points x, y, z in 3 space whose z coordinate is are positive. So what is this? X, Y, Z. So it represents all the points in the X, Y, Z space which lies above the XY plane, so that the Z coordinates are always positive. So it is just the set of points above the XY plane. Okay? Yani bu X, Y düzlemini alıyorsunuz. You just take the XY plane, which is this XY plane, and this space is the set of all points above the XY plane. Okay? It is, of course, analogous what you had in R2. For example, consider this x equals x is positive. That corresponds to all the points, right, in the xy plane where x coordinate is positive. So it is just the set of all points on the right hand side of the y-axis. Here it is the set of all points on the above the xy plane. Okay. Another one, the inequality x squared plus y squared plus z squared is less than 25 represents all the points whose distance to the origin is just square root of this, which is 5. So it represents all the points whose distance to the origin is less than or equal to 5. So what is this? This is just the set of all points on the sphere and inside the sphere given by this equation, x squared plus y squared z squared is equal to 25. So you just take the sphere of radius 5 with center at the origin. Okay, so it is just this sphere, and this set represents, so this is x squared, y squared, z squared is 25, and this represents all the points on the sphere and inside the sphere. Okay, so this inequality is the set of all points inside the sphere and of course the points on the sphere. Okay. As you have noticed, we are just considering equations of degree 1 or degree 2, right? Either x, y, z or squares of them. We don't even talk about equations like this, for example, x cubed plus y squared minus z minus 1 squared y equals, let's say, 5. Okay? Why? Well, because, these are difficult. Okay? It's not easy to graph these gadgets. And actually, today, we don't know how the surface represented by an arbitrary polynomial looks like. We have classification up to like degree 7 or 8. Okay, it is not just I don't know, but nobody knows. Even using computers doesn't help. Okay, if you write down an arbitrary equation, even degree, let's say 15 in x, y, z, how the object described by that equation looks like, we don't know. Okay, nobody knows. And computers doesn't help. Okay, and what happens is that as the degree gets higher and higher, more mathematics goes inside. Okay, it involves not only analytic geometry like this, but it actually requires a lot more theoretical mathematics, including algebra, analysis, and many things. So it's a very deep actually subject, and it has a name. It's called basically Hilbert's 16th problem and related problems. In 1900, there was an international conference, and in that conference, Hilbert gave a list of problems, and he said, okay, in the 20th century, this will be the focus of mathematics, and this is the 16th problem in that list. Okay, uh, and it is still it's not it is still unsolved. We understand some part of it, but we don't understand most of the cases. So even though these things looks easy, if you deal with equations of degree 1 or 2, in general it is a very difficult problem. Okay. Yeah, people are studying this, but it gets very difficult. Yani su çok çabuk derinleşiyor. O yüzden de böyle işte derece 7-8'de işte çok büyük bir gelişme oluyor ama hani derece 10 için ne olur bilmiyoruz. Ve bilinen matematiğin çoğu konularında kullanmaya başlıyor. Yani sadece burada kalmıyor. Diğer alanlardaki bilgileri de buraya taşıyorsunuz. Yani oldukça böyle sofistike bir matematik var. In general, this kind of things are called algebraic geometry. Why? Because they are geometric objects described by algebraic equations like polynomials. Okay, that's why this is called algebraic geometry, and it is one of the most difficult areas of mathematics. Okay, let's do more examples, at least the ones we understand. We may consider systems of equations, for example, like this one. So what is this? Well, each equation of this type represents a plane. We already considered this x plus y plus z equals 1. So it was actually this plane, right? 1, 1, 1 here. You just join these points. You get this triangle. and then you just extend it. So it is the plane containing this 3 points. It is not easy to draw, but you know, it is just going in all directions like this. So it is this plane. Okay. What about y equals 2x? Well, y equals 2x in the xy plane, it is just this line, right? Y equals 2x. It is just this line. What about in the x, y, z3 space? So y equals 2x. Here x-axis is, okay, şöyle yapayım. X, y, z. X equals 2y is y'ye daha yakın olacak. So it is just this line, right? It is just this line. Y equals 2x. In 3 space, of course, this represents a plane. Which plane? You just take this line in the xy plane and you translate it along the z-axis, right? So when you translate this along the z-axis, of course, you will get this plane. So this system of equations represents then, right? It is the set of all points satisfying both equations. It means it is the set of all points on the plane given by these equations. So it is nothing but the intersection of these two planes, right? Because it is both on this plane and on this plane. So this system, this system of equations represent all the points in 3 space which lie on both planes. Okay. Yani hangi plane'ler x, y, z eşittir 1 and y minus 2x equals 0. Therefore, it is just the intersection of these two planes. Well, intersection of two planes is what? You take two planes in the space, when you intersect them, okay, they can intersect any, I mean, like this, for example. Intersection is a line. So it's a line. Okay. It is difficult to imagine, right? You take this plane containing this triangle, and then you just cut that plane with this plane. Okay. So it will be a line. Bu z'ye paralel. Değil mi? X-Y düzlemindeki doğruyu alıyorsunuz. Z olmadığına göre burada bu ne demek? Z her şey olabilir. Yani bunu alıyorum, Z ekseni boyunca kaydırıyorum. Tamam mı? What about this one? X squared plus Y squared plus Z squared equals 1. X plus Y equals 1. One of them is a sphere, right, of uh, radius 1, center at the origin. So it is this sphere. Okay. What about the other one? The other one is a plane. Şöyle yapayım hatta. X, Y, Z. Which plane? Well, you take the x plus y equals one uh, line. It is this line, right, in the xy uh, plane. 1, 1. And you just translate it along the x-axis, z-axis, pardon. Now, these points are, right, this point is 1, 0, 0. This is 0, 1, 0. And this point is 0, 0, 1, right? The points, this axis intersects the sphere are the points 1, 0, 0, 1, 0, 0, 0, 1, 0, and 0, 0, 1, right? These are the points where the axis intersects the positive x, y, and z lines. My line is this line here, so it is inside the sphere, and you cut this sphere by the plane containing this line, so you just translate it. So it is a plane like this, right? It is this plane here. So when you cut this sphere with this plane, you will get a circle like this, I guess. Değil mi? Bir küreyi düzlemle keserseniz her zaman bir çember elde edersiniz, değil mi? So it will be a circle like this. Right? This circle lies in this plane, x plus y equals 1. And actually it is just the part of the sphere. Okay? Yani kürenin böyle üstünü bir şeyle, düzlemle kesiyorsunuz. Efendim? Gibisi fazla. Tam ara kesiti. Hı hı. Peki. Evet. Burada da resimler var. Hani onlara bakabilirsiniz. In the exercise there are, similar gadgets, a lot of them. You can work on those. Okay. Belki şeyden bahsedebilirim. Euclidean and space. Well, we studied real line, plane, R3, three-dimensional space, and you can just keep going and study n-dimensional space, Euclidean space. What we mean by Rn is this. N tuples of coordinates, okay? If you have just two tuples, then you have plane. if you have three tuples x, y, z, you have three space, but you may consider n tuples like this. Okay. Of course, so they are all real numbers. We cannot draw a picture of this, realistic picture of this. What we do in general, if we work on Rn, we represent it again like it is R3. So we usually do this. Let's say x1, x2, xn. We write. Okay. We draw pictures like this. This is called the Euclidean end space, and everything we have done for real line R2, R3, or Rn, most of the geometry can be translated over here. So we may consider, Euclidean end space. Sometimes we need it. Okay. There's this interior, exterior stuff, but let me omit that. Okay. Ya da bilmiyorum, bundan bahsetsem mi? Kalsın. Okay. Next section is vectors. So a vector, so let's describe what's a vector, is a quantity that involves both magnitude which is usually size or length, and direction. Okay, it's like velocity, right? Velocity has two components. One component is the speed. That's the length of the velocity vector, the speed, and also it has a direction, right? Velocity is a vector. It has a magnitude and a direction, right? If you are going in some direction with a certain speed, then the two, we can represent both of them in a single object, a vector, right? So it has a direction. You are going in this direction with certain speed. Speed size or length corresponds to the length of this vector, velocity vector, and direction just gives you the direction in which you move. Okay, so şöyle yazayım. For example, the velocity vector contains the information şöyle diyeyim, contains both the information okay, how fast the object moves which is the speed, and in which direction, right, the object moves. For example, let's say if the velocity vector is like this, uh, suppose its length is let's say 5 units. So this length corresponds to speed, okay, of the object, and the direction tells you in which direction the object moves, okay. So it moves in this direction with speed 5 units per second, let's say, okay. So vector is a uh, is an object which contains basically two information: uh, its size, which corresponds to some length or speed or some other quantity, and a direction, okay. Okay, how we represent vectors in space? Well, for example, if we have 2 points, let's say A and B, then this 2 point represent a vector. How? Well, you may consider the line segment from A to B, and we usually write it like this, represented like this. So this is the vector from A to B. Let's call it V. So this is A, B. And to represent that this vector goes from A to B, we also put an arrow like this. So the vector starts from A and goes to B. Okay. The magnitude of the vector V uh, is the length, is the distance from A to B. Okay, so it is just the length of this line segment. Okay, all right. Uh, two vectors, let's say V AB, and let's say U CD, okay, CD, uh, so that ilki şu, uh, length'ini nasıl gösterecektik? Ha, şunu da yazayım. The length of V is denoted as şöyle, V'nin boyu or the uh, uh, this distance from A to B, okay? We denote it like this: length of V, or the length of the line segment from A to B. And if we have two vectors, okay, let me write this line over here. Two vectors, I am writing the same thing. AB, let's say, and CD, so that First, length of V is equal to length of U. So the same length. And second, and U and V are parallel. V and U are parallel. Will be considered the same. Yani yönü ve büyüklüğü aynı olan iki vektörü biz genelde aynı kabul edeceğiz. Tamam mı? Yani şu vektörü alın. U vektör, V vektörü. İşte AB olsun şöyle. Tamam mı? AB vektörü. Bir de U vektörü var. O da şöyle mesela. Öyle ki bunlar birbirine paraleller ve boyları da aynı. Paralelden kastettiğimde nedir? Birini hiç döndürmeden taşırsam işte bu C noktasına A noktasına D noktası da tam B noktasının üzerine geliyorsa o zaman bunlara paralel diyoruz. Eğer böyleyse bu vektörleri biz aynı kabul edeceğiz. Tamam mı? Evet. Ee, yok. Aynı, o yönü ters. Tamam. Doğrular paralel ama burada bir de direction'ımız var. Tamam mı? Hani şey değil. So this vector is not the same as this vector. Okay? They represent, they are both on the same line, but their directions are the same. And physically, you shouldn't consider these two things the same, right? It's going, one of them is going in this direction, the other one is going in the opposite direction. So they are completely different vectors. Although they lie on the same line, they are different vectors. This way, we can always translate a vector so that it starts from the origin, right? Because, you know, whenever you have a vector in 3 space, let's say you have a vector like this, you can just translate this point to the origin and you obtain a vector like this. So for us, this vector and this vector will be the same, as long as they are parallel and have the same length. Okay. Okay. All right. We can do arithmetic with vectors. We can add them up. Addition. Geometrically, it is described as follows. Whenever you have two vectors like this, let's say a vector u, another vector, let's say v. How do we add them up? We just translate one of them so that they have the same initial point. So initial point of this vector is this point, initial point of this vector is this point. I just, let's say, translate this vector so that they have the same initial point. So I have this u, and then the sum of these two vectors is defined as follows. You draw parallels to these gadgets. So what you do actually, maybe I should say it differently. You just add, translate this vector so that it starts from the point the other one ends. So take this point and carry it over here. The tip of this vector is the end point of the addition. So this one. Yani birinin bittiği yere diğerinin başladığı nokta yapacak şekilde kaydırıyorsunuz. So the tip of this vector v is this point, right? I just carry this vector over here. Then the starting point of the vector v plus u is this point, the starting point of v, and the end point of v plus u is the end point of v. Once it is carried so that it starts from the point where v ends. Tamam mı? Nasıl? Ee, tamam, ona da geleceğim. Or you can do the following. You just, let's say, take v and you carry this u so that they have the same initial points, and then you form this parallelogram. You draw parallel sides, and then you take the diagonal. Okay, you take the diagonal. This is u plus v, or v plus u. You can do both ways. Usually the second one is used. Okay, you take both vectors with the same initial point, and then you form the parallelogram and you take the diagonal. Okay, that's the sum. From this, of course, observation, this one, note that this operation is commutative. So v plus u is the same as u plus v. It is not clear from this that you have this, but from this picture it is clear, right? From the second description it is clear that v plus u and u plus v are the same. Okay. And we have scalar multiplication. What's that? If lambda is a real number, you can consider, one can consider, and suppose this is a vector, a vector, we can consider lambda v. What is this? This is the same, this is the vector. This is the vector parallel to v with size lambda times size of v. If lambda is negative, then you take, of course, the if lambda is negative, then you okay, take the vector in opposite direction. Yani şöyle tarif ediliyor. Suppose this is our vector v. Okay. This is 1/2 v. The same vector, but so it is parallel, but the length is half of it. Okay. Minus v is this vector. It is parallel with the same length, but it goes in the opposite direction. Okay. Minus 1 or 2v is this one. Okay. You take both its negative and then divide its length by 2. Okay. All right. Okay. What else? Ara verelim. Let's give a break. After the break, I'll continue.